Hello everyone, I'm Alon and today we're going to talk about how to compute the moment generating function. So in order to do this we need first to talk about a reminder for Maclaurin series, and instead of talking about f of x, I will talk about f of y, which is basically the same thing because I'm going to use x for something else. So we know by Maclaurin that this is approximately f of 0 plus the first derivative at 0 times y plus 1 over 2 factorial times the second derivative at 0 times y squared plus 1 over 3 factorial times the third derivative times y to the cube, and so on, and let's stop here. So this is from Maclaurin, also known as Taylor at 0. So now let's consider instead of an arbitrary function f of y, let's talk about f of y, which is equal e to the y, and we need all of its derivatives, and we know that no matter what, the derivatives, the first one and the second one and the third and all the rest, will be always e to the y, and we need to put instead of y 0, so we know that at 0, when we want to see at 0, we know that e to the 0 is 1. So now let's see what happened to this function, function f of y, which is e to the y, when we want to do Taylor to it. So f of 0, we just it's e to the 0, which is 1, plus the first derivative at 0 is also 1 times y, so times y, plus 1 over 2 factorial times the second derivative at 0, which is 1 times y squared, plus 1 over 3 factorial times the third derivative at 0, which is also 1 times y to the third, plus many other kind of terms. And now I want to think about, instead of y, I want to say, instead of y, let's talk about theta x. So it will be the same, just wherever you see a y, we will replace it with theta x. And what I mean is that instead of function of y, we can write function of theta x, which will be e to the theta x. So according to Taylor, it will be approximately 1 plus 1 times y, just y, but y is theta x, plus 1 over 2 factorial times 1 times y squared, y is theta x, so times theta x squared, plus 1 over 3 factorial times 1 times y cubed, but y cubed is theta x cubed, and so on. So now you know why I didn't want to use the x in the first place, because I wanted to use it now. Now let's talk about what we really came here for. Let's talk about the moment generating function, and the moment generating function of our variable x defined as the expectation of e to the theta x. This is how you compute the moment generating function, but we just saw that e to the theta x, we can write it as a Taylor series, which is to say that instead of e to the expectation of e to the theta x, we can take the expectation of this right here. So it will be expectation of 1 plus theta x plus 1 over 2 factorial times theta x squared plus 1 over 3 factorial times theta x cubed, and so and on and so on. And this is equal because this is an expectation. We can take the expectation on each part here individually, so it will be the expectation of 1 plus the expectation of theta x plus the expectation of 1 over 2 factorial theta x squared plus the expectation of 1 over 3 factorial times theta x cubed, and so on. And let's take all the constant out of the expectation. So the expectation of 1 is 1, and here we can pull the theta out of the expectation, plus here we can pull out the 1 over 2 factorial, and from here we can take out theta square times the expectation of x squared, plus here we can take out 1 over 3 factorial and theta cubed times the expectation of x to the power of 3, and so on. So this is our moment generating function. And why does it call this way? Because if you will notice here, let's change color to yellow. Here we have, this is called the first moment, this is the second moment, and this is the third moment. And of course, if we will continue, we'll see all the other moments of this function. And to get to them, all we need to do is to take the derivative of this moment generating function with respect to theta. So if we will take the first derivative, the 1 will go away because it's a constant. Here we have theta, so if we are deriving it according to theta, we'll be left with theta x. Here we'll get 2 theta divided by 2 factorial times the expectation of x squared, plus here according deriving this according to theta will get us 3 theta squared over 3 factorial times the expectation of x to the third, and so on and so forth. Now the important part is, if we will evaluate this derivative at theta equals 0, which means put 0 wherever you see theta. So here we'll have 0, so this will all go away, and here we have 0, so all of this will go away, and we have other terms here also with theta, so they all will go away, and we will left with e to the x, which is the first moment. Now let's talk about the second moment. If we want to compute the second moment, just derive this moment generating function again with respect to theta, and this first term, which is constant, will be 0. This second term will be just 2 over 2 factorial is 1. We are making the derivative with respect to theta, so theta will go away, and we will left with this 3 over 3 factorial. We have here, I'm sorry, 3 times, when we derive this, is 2 theta over 3 factorial I'm running out of time, so we'll continue this in another